All right, so welcome to my talk this morning. This is going to be on DKEY, or data destruction at scale. Just want to go ahead and introduce myself to everybody here. My name is Drew. I've worked in enterprise and I've worked in startups. I usually work primarily on the physical infrastructure side, so servers, data center, networking gear, the whole, kind of that whole shoot and match up to the OS. So I'm here today, I'm representing myself and some stuff I've worked on in my own time, not here at the benefit of my employer, but this is based on stuff I've encountered, particularly this talk is based on stuff I've encountered at work. So forgive me if I'm intentionally vague about who I'm working for. So this is my first Freaknik and my first time speaking at a conference. So as you can tell by all the nerves in my voice, this is a new anxious experience for me. And clearly, I have no idea what I'm doing. All right, so contents of the talk. I want to do just kind of a brief overview of what DKEY is, some background of how I got to doing DKEY, an outline of the script, some limitations that we have so far with it, and then the big part is actually scaling the script. So DKEY is an open source Python program I wrote. It's based on experiences that I've had in my professional life working on web-scale infrastructure. What the idea is that it's going to allow drives to be erased on a remote machine with both securely encrypt and destroy all of the data that's contained on those disks. And then I'm going to also go into some of the thinking behind this as well, because it's kind of, to me, it's serendipitous how I came to this. All right, so here's the background. What do you do when you need to get rid of a bunch of disks in a server? What do you do when you need to get rid of a bunch of servers? And what do you need to do? What do you do when you need to audit getting rid of a bunch of disks and a bunch of servers? So ultimately, I want DKEY to solve all of these problems. Is anybody familiar with Derek's Nuke? All right, so DBAN is great. Once upon a time, we were using DBAN sequestered off-network files, or off of the network, just running it off of USB sticks. And DBAN works great when you're working at certain scales. If you have any certain number of disks per host, any certain number of hosts in your environment, and then how many hours you have to complete all of your wiping projects. So let's say you're like me, and you have a bunch of storage servers, and someone emails you on Sunday, says that they're flying out from California. You have, let's see, you have 120 servers to wipe, and each server has 36 terabytes of storage. So the whole cluster has 4.32 petabytes. Truck is going to be there on Wednesday. So all of a sudden, DBAN doesn't scale anymore. So with the original incarnation that we wrote for this, let's see. Okay, yeah, so we took the repetitive overwrite model from DBAN. It was a great idea. Flaws about overwriting data are scientifically, theoretically possible, but haven't necessarily been proof of concept real world. At least if you're not talking state threats. So in the original incarnation, we were also using guidance from the NIST SP800 that talked about encrypting the drives, because you could just theoretically just encrypt everything and put it on a truck and hope it makes it to the other side of the country. But our security team at the time was saying that that's not, according to this document, which we base everything around, encryption itself is not secure without just removing the key. So now we need to figure out, what can we do in the meantime? So has anybody listened to the Defensive Security podcast at all? No? Okay. They have a Slack channel, and I'm at work, theoretically working one day, goofing off on Slack, and somebody mentions in the channel that, has anybody thought of using crypto locker type malware to encrypt all of your drives and be able to dispose of stuff securely? And I was like, oh yeah, I had been thinking about doing that already. So we got to talking, and I figured if somebody else is thinking kind of like I am, that maybe I'm onto a good idea. All right, so the outline of the script, I chose to write this in Python for a variety of reasons. It's modular, that's beneficial to me, who's not a good coder and is still very much learning the ropes. It's flexible, so the script can grow, and we use Python extensively at work, so I was able to bounce ideas and get code reviews from some of my colleagues who are much better at this than I am. And ultimately, this is going to work on what I think of as a garbage in, garbage out principle. So when the script runs, it's going to detect all of the hardware that's connected to all the storage devices. And then it's going to determine whether you have a rotational hard disk or solid state media, because we need to treat the wiping phase of those differently. All right, so when we do the encryption, it's broken down into two different methods. We have a keygen method and the apply crypto method. Since I work in a Linux environment and I prefer Linux entirely, it's all written based on Linux. So we're using crypt setup as part of dencrypt to encrypt the drives. The keygen works in phases, so it generates 3 unique keys. And then each key is applied, or 1 key per phase of the crypto. So we do this, to ensure compatibility within different kernels, and we're able to adhere to crypto rule 1, which is don't roll your own, because crypto math is hard. So when we encrypt the drives, since we're using the crypt setup, we take the keygen files that we've created, and we're going to use 3 different algorithms and apply to each drive 3 rounds of crypto. I went ahead and stored the key files in /temp because it's volatile memory, and that's a good way to ensure once a machine is powered off that all of the keys are stripped from the machine and can't be reused. So here's my awful code. So we're essentially just doing a loop. We're taking advantage of AES, Twofish, and Serpent. We're using different, not only different keys, but also different cipher methods so that we don't have any collision errors that could cause a drive to be decrypted on a subsequent round of crypto application. So we follow a loop, hitting every attached drive with the crypto for 3 rounds. And we went with industry standards, AES, Twofish, and Serpent. And then using 3 layers crypto. Yep, okay. So now that we have our data encrypted, we start with our wiping methods. SSDs have internal secure erase functions built into its firmware that allows us to clear the data while preserving the overwrites that you can have with SSDs. So you could repurpose this hardware, say if you needed to move it to another cluster or you wanted to move it to another location that's going to go back into some sort of software role. If it's a full decommission, you really don't care about the lifespan of the SSD unless you're going to try and resell it. So I thought it was better to just kind of separate the SSDs from the rotational media and apply the firmware secure erase. Let's see. So here we have, using HDPARM, you can verify whether or not a SSD is frozen or locked, which means you have to do some hardware manipulation to disconnect power to the drive and get it to unlock. I haven't run into this very frequently in our environment, but I have run into it enough that I figured it was a good enough check. And then we use the subprocess.call method to apply setting a garbage password to the drive, and then using that garbage password to do the security erase. And then once the security erase is applied, obviously the password goes with it, so that the whole drive is done. Unfortunately, the drive firmware, particularly the erasure part of it, the firmware itself isn't open sourced, so we have to rely on manufacturers to basically just say, trust us, this is what securely erases your data. I haven't found any validation errors or been able to resurrect data wiping things in my environment, so as far as I can tell, it works, and I haven't seen any papers or presentations or anything like that that announced the contrary. Still makes me really nervous that someone's just like, yeah, trust me. So for the hard disks, the rotational media, we're going to apply a similar method as we would have with DBAN, looping multiple passes. I have 3 coded in there right now. To just overwrite the data on all of the available sectors of the drive. We're using dev random with DD, because this destroyer is great. This minimizes system resources for entropy, while also giving us a reasonably strong variance of data to overwrite on those drives. Some people in the past have suggested that we use shred, which is another Unix-like command that does multiple overwrites. However, the amount of time that shred utilizes to do all of its overwrites, we found that we get a better performance out of using dev random. So here's the disk wipe method. As you can see, it's just a series of loops overwriting each drive, and then as long as we have no errors, ideally, it will pass through each phase. If we get errors, then we can write that to a log, validate, and then we can physically destroy any drives that we encounter with errors. So in summary, we just have a series of loops that do encryption and then erase and overwriting for each drive attached to a system. This is kind of where I call it the garbage in, garbage out. We're taking whatever data existed on that, and by running these multiple crypto algorithms, we're kind of making it just this big pile of garbage. And then we're going to overwrite things multiple times so that if there's anything left, all it is going to be traces of garbage. And then, as I said, writing keys to temp data as soon as the machine is powered off. We're going to lose all that key information there too. So, and the idea is that each layer builds on one after another, and hopefully increases our fault tolerance of the script overall. All right, so some obvious limitations. It's written for POSIX systems. I'm sure it can run in BSD if you have all of the necessary libraries and packages. I haven't tried it because, like I said, we're a Linux shop. Ideally, I'd like to make a Windows version of this, mostly for the excuse of learning PowerShell, but also I feel like we could see a much wider adoption rate of this if it worked on Windows as well. The audit portion isn't fully functioning yet. Actually, I wouldn't even say it's barely functioning yet. So ideally, I'd like to collect machine and drive information, be able to write that to a third remote host. And as of now, we just have kind of a functional script. Oh yeah, actually, one other thing that I noticed as I was toying around with this a couple nights ago, the way I've done the for loops is that it only does one drive at a time. So really the next scaling challenge will be to do every drive concurrently rather than consecutively. That's how you get through those storage systems, by the way, is doing everything consecutively. So ideally scaling this is to get this packaged with some RAMFS image that you can put on a Pixie server. The way we do our infrastructure at work is everything boots off of a Pixie server, regardless of whatever anyone else tells you, and we can load all of those RAM images. And this also gives us the added benefit of being able to wipe SDA and have the script fully run because it's all running in memory. And that way we don't have traces of a root file system existing when we decide to pull something out of the environment. So we've gotten this down to, as I said, we were using DBAN before. We could maybe do the span of 50 disks across like 3 systems with the DBAN setup we had before, and now we've gotten to the point where a single engineer, a single administrator can go in and wipe entire racks up to and including an entire data center worth of material. That's how the work version works. This one is still a little more rudimentary, but ideally that's the type of scale we're aiming for, is being able to have an admin take care of an entire site. So this is definitely a much more efficient scale than people walking around moving USB drives or making 120 USB drives so that you can wipe 3 racks of servers. So, like I said at the very beginning of the talk, I'm a very novice coder, so I'm sure you've probably noticed a bunch of bad things that I've done in just the slides alone. So if you'd like to go ahead and get a copy, I'm happy for feedback and contributions. It can be found at github.com/dasseclab/DKEY. And then you can follow me on Twitter at dasseclab, or you can get in touch with me via my website at dasseclab.net. I'll have definitely like slides and everything like that posted up once I get back home to Atlanta. I blew through my 30-minute talk in about 17, so does anybody have any questions? Yes?
Have you considered using the HD Parm enhanced secure erase versus regular secure erase for SSDs and HDDs?
I have. I do find the time requirements on secure erase via HD Parm are a little bit longer than I would like, but it's certainly a very valid method.
The key thing with that is if you use DD, dev urandom, it'll run, hit a bad sector on the hard drive, it'll stop.
And fail, right.
Yes. And also HD Parm's secure erase command will actually overwrite bad sectors on hard drives.
Okay, so I wasn't aware of that, so that's definitely something I want to look into then. Great, thank you. Yes?
There are some drives that are hybrid drives where they're part solid state and part regular platters.
Okay.
And if you're storing your keys there temporarily on your first 3 steps, and then you power it down, isn't there a chance that it's actually in flash RAM memory there that you don't have really a port to be able to erase?
I suppose.
Especially in temp, where it's going to be, you want it to be a fast drive.
Yeah. I suppose that is the case. I haven't encountered any of the flashbacked platter drives yet, so that's definitely something I want to look into. Yeah.
You were talking about making it run in parallel. In general, what's the CPU usage for like encrypting drives like that?
There's a little bit of spike, but I don't recall off the top of my head.
It's definitely not a CPU bound process, though.
I don't think so. No. Yes.
I was going to also say with the internal secure erase, it's all on the actual hard drive itself. There's no CPU usage.
Okay.
So that'll scale.
Yeah. So we can definitely offload that. Yeah.
Also, I've actually looked into doing this very same thing for my own purposes.
Yeah.
A flash of brilliance, make file. Create a very dummy make file, and then say run this job with like 18 hard drives. It'll do 18 at a time.
Yeah. Okay. That's a good way to do that. I wonder if you could do the makefile on the fly.
Do it in temp.
Yeah, do it in temp, and that way it wouldn't necessarily matter how many drives were attached. So you could go from, say, your 12-drive storage server, but also your 2-drive web server.
Or just create a for loop that just does a for I in dev SD question mark.
Yeah. Yeah, I like that. Okay, cool. I'll have to try and remember that. Well, thank you very much for attending my talk, and thanks to Briefing for letting me talk.